Hi, this is Rahul Barnwal, and I would be teaching you merge sort algorithm, which is a like sorting algorithm which is most commonly used. So before starting merge sort algorithm, let me tell you what the sorting actually means. So sorting means that let's say if you have been given an array, which you can see on the screen currently. Let's say we have 9, 3, 7, 5, 6, 4, 8, 2, and you want to sort it. So you would expect the end result to be like in an like increasing order, right? So it will be like 2, 3, 4, 5, 6, 7, 8, 9. So the this array should be basically in an increasing order, right? So there could be duplicate elements, so they will be like occurring simultaneously. Like if let's say there are like two occurrence of six or three occurrence of six, then 666 will be occurring simultaneously in there. So let me like set the context for this. So first of all, merge sort is a divide and conquer algorithm. Now I will tell you in a bit like what is divide and conquer and all those stuffs. So let's move forward. So my main goal is to basically sort this array. Now, what this algorithm does is, let's say I have this array. Now its size is basically 8. So what we will do is we will basically mm, kind of split it into two parts. Let's say if I'm splitting it into two parts, so the first part will be 9375 and the second part will be 6482. Okay. Now what I want is I want this first part to be sorted and the second part to be sorted, and then we can kind of merge it, right? What I'm saying is, what I'm expecting is this 9375, this 9375 should be this 9375 basically it should be basically sorted and it should get to this particular result 3579. And similarly, the second half which I am having, which is 6482, this should also get sorted, and the end result which I will be getting will be 2468. Right. So when I will get these two, sub arrays, these are sub arrays of this particular array. So when I will get these first half and the second half as sorted individuals, then we can kind of merge it, and then we can get the main, our sorted array. So we have this 3579, we have this 32468, we can kind of merge it, and then we can get 234678. Now, see, there are multiple algorithms which uses brute force approach or some kind of n square approach to solve, this sorted array problem. But the thing is, merge sort does it in a very less time complexity as compared to the other sorting algorithms. Now, the thing is, let me start with a merge sort function. So let's say I have this merge sort function, which is having low and high. Now, what is this low and high? Low and high are simply the lowest index and the highest index which we are having for the particular array. So let's say my target array which I want to get sorted is basically this one. So the lowest pointer will be pointing to this first element and the highest pointer will be pointing to the last element. Now, what I want is I want to get this whole array sorted. Okay. So what I will do is just look at this part, this blue part basically. So what it will do is I want this, this particular part to first sorted, then this particular part to get sorted secondly, and then we wanna basically merge it. So now we will use recursion for it. Now in recursion, what happens is basically one function calls another function, right? So it calls kind of the same function each and every time. So if you will notice here, we are doing the same here, right? We are having a merge sort function in which we are passing this low and high, and it is again calling this merge sort again, correct? So it is calling this as with some another parameters. That is okay. Now in recursion, what happens is I will assume that this particular first subproblem, my first subproblem is what? This array 9375. This is my first subproblem. And second subproblem is basically 6482. So I will assume that I'm calling the merge sort on this first array 9375 and it is getting sorted. That I'm assuming. I will let recursion handle this particular sorting of the first subpart. I will not do anything. I will just assume that this is sorting it. Okay. This is the basic funda of recursion, like how we write the recursive code. Okay. So first thing what I will do is I will expect this merge sort call to basically sort this first sub problem. Now, so input of this particular first sub problem will be 9375 because it is the first part of the array. Now, what is my expectation? My expectation is basically 3579. My expectation is that this subpart will get sorted when I will call the merge sort on it. So I'm assuming that at this point, my first half is sorted. That is what I'm assuming, right? Now, at the second call, what I will assume is that my second subpart is sorted. That I will assume. How it is sorted, that I am not taking care currently. Currently, I'm not taking care. Recursion will handle it. That I don't have to worry about, right? So here, for the first line, I'm assuming that I have now got this particular 3579. Okay, and on the second line, I'm assuming that I have got this 246 that as my sorted array, right? So now, according to my assumption, now this 3579 is sorted and 2468 is sorted, right? Now, what is left? What is left after doing this recursion? What is left? The last thing left is to basically merge these two sorted arrays. Now, merging these two sorted arrays is maybe you could be familiar with it. This is very easy. You know, if you're not aware of this particular method, then I can make you like aware of it. So so let's see here. So we have a merge kind of function in which basically we will pass this low mid high. But before that, let me tell you one thing. In this merge sort which I have done, the first call of the merge sort, here we are passing low and mid, right? Why low and mid? We are passing only this part, right? Only this part, low and mid, low till mid, and then from mid plus one till high, right? Mid plus one till high for the second part. So basically, this is the one, mid plus one till high. So I'm assuming that this call will make the first half sorted and will make the second half sorted. Now, here I have got this as sorted. I mean, the two parts, I have got them as sorted. Now, what I want is to merge them. So that is why I'm basically going to this merge algorithm. Now, what this merge algorithm will do, it will take this 3579, it will take this 2468, and it will merge them to a resulting sorted array, which will look kind of this 2, 3, 4, 5, 6, 7, 8. This is how it will look like. Basically, I will get this sorted array, I will get this sorted array, and I will take them as input, and I will basically sort it. I will basically kind of merge it to into this array, right? So, so what I'm doing is, see, this is 3. This is 2. Now, which one is shorter? Which one is shorter? Tell me, which one is shorter? 2 is shorter, correct? So I will take 2 and kind of insert it in my temporary array. Now, so since I have taken 2, I will move forward. Now I am at 4, correct? I am at 4. Now, I will compare this. Now this 3 is there itself. It hasn't moved, correct? So comparing this 3 and 4, which one is shorter? 3 is shorter, correct? So I will take 3 and I will simply put it. Now, since I have just taken this, I will move the pointer to 5, correct? Now, between 5 and 4, which one is shorter? It is 4, correct? So I will take 4 and I will simply move this. Now, between 6 and 5, which is shorter? It is 5, correct? And I will move this particular pointer, 7. Now between 6 and 7, which is shorter? 6 is shorter. So similarly, it will be like 6, 7, right? 6, 7, and then 8, correct? Now after we will take the 8, this will basically overflow. This will overflow and it will get out of bounds. It will get out of bounds. Now, because this since this array, all the elements of this array has been taken. But there is one thing. All the elements of this particular array hasn't been taken yet. 9 is still left. 9 is still left, right? So for that, to handle that case, that any elements could have been remaining in either the first part or the second part. To handle that case, we have this. either left array is not empty yet or right array is not empty yet. So we will simply move forward in that array and we will push the remaining elements in our temporary array, which will be 9. So that is what are we doing here. This is the same logic which I have done. Basically, it is comparing the like which is each one is shorter, and then it is storing it, and then kind of moving forward, and then again comparing. So this is what is happening here. And if there are any remaining elements in the first subpart or in the second subpart, then we will be storing it later, right? So this is that part, correct? Now, now the elements are in the temporary vector. So to store it in our original array, we are doing this particular call, right? So this is a very simple basic explanation of the merge function. Now this was not needed for the merge sort, but just in case if you do not know, then I am telling you, right? So let me just clear it. Yeah. Okay. So just quick. Yeah. So yeah. So at this point, we have got the array sorted as 3579. At this point, we have got the array as 2468, correct? We have got the array as 2468. Now, at this point, at the merge point, what we have got? We have got the merged of these sorted two arrays, these sorted two arrays, right? So we have got basically this result. We have got this result. And this is what I wanted. This is what I wanted. This was the end result which I wanted, correct? I do not have to take care like what is this merge sort doing? What is this merge sort doing? I do not have to go into deep dive. I will let the recursion take care of it. I will let the recursion handle this. Okay. I do not have to think about it. This is how you think of a recursion problem in very simpler way, right? You have to basically assume that a recursion will solve it and I will move forward doing another operation. That is what you have to do, right? Now, I haven't told you yet what is this particular first line. I will not tell you currently. I will not tell you this currently. I will move forward and then I will tell you. So now, what is happening? I will give you a dry run. So 9375648 currently, see, we have we have called the merge sort firstly on this, then on this, right? Now, when I will call merge sort on this, then it will go ahead and it will again break it into two subproblems, which will be 9, 3, and 7, 5. And again, it will break to the 9 and 3. Now, now I will tell you what is that particular line which I have written here, right? So, uh, up till when I will continue, up till when I will continue, because what I'm doing is I'm calling same function inside the function, right? I'm calling merge sort function again and again inside it. So it will kind of go till an endless loop, right? If I will not give an halting condition. So for that halting condition, what will be that halting condition? So that ending condition or that basically base condition, which we call it, what will be that? What will be that? Now, if you will think about it, for thinking about a base case, what we can assume is consider a very small data. Consider a very small data. So let's say I have just two elements, which is 9 and 3. Let's say I have this 9 and 3. So where will be the left? Left will be at the 0th index. Where will be the edge or the high? The high will be at the 1th index. So here L is at the 0th. So if I may write, so L is basically 0 and H is basically 1. Correct. Now, let's say if this has been boiled down to 9. Now, if it is 9, L will be 0, H will be 0. Correct. So after this, we will not continue. After this, we will not continue. So up till when we are continuing, when L is lesser than equal to H, then only we are continuing. If it is lesser than equal to H, then only we are continuing. So when we should halt, we should halt when L is greater than H, right? We should halt when L is greater than H. This is the base case of our algorithm, correct? So this is what I have written here. If low is greater than high, then we should like simply return. think of a very small sample space. Think of a very small problem to get the base case. That is how recursion works, right? So let me just quickly remove it, or let's keep it. So now we have got this 9. Now this 9 is already sorted. This 3 is already sorted. What we have to do? We have to merge it. We have to merge it. How will we merge it? That same algorithm which I have told you. This one. So when we will merge it, we will compare 9 and 3. Which one is smaller? 3. 3 is smaller. So I will take 3 and insert. Now, 9 is remaining, but this has been basically, this has been this has been done. But since some of the elements in the first subpart has been remaining, so 9 will be added. So 3 9 is here, then again simply 5 7 is here. Now this one is sorted, this one is sorted. Now what we will do? We will do the merge. We will do the merge. Again 3 5 7 9. Now similarly here 2460 is sorted, 3579 is sorted. What we will do? We will merge simply. So this is how the divide and conquer works and how the recursion works basically. Now, so this particular tree, recursive tree, which we have got, this is basically known as recursive tree, which we have just plotted. So uh, this this first part, which you can see in the blue, is basically divide, because what we are doing is we are dividing the array into multiple subproblems, right? We are kind of basically forming a tree. We are forming a tree, right? And we are dividing it into subproblems. Concur means basically concur what you have got, right? Concur means again kind of recombine them to get your result. So that is basically concur, right? So I'm assuming that you are clear till this point. Now, one thing which I would like to mention is the time complexity. What will be the time complexity of this particular algorithm? So let's analyze it very thoroughly. So I'm assuming that this particular array has n elements. Let's generalize it to get the time complexity. So we have n elements. Let's say we have n elements. Now, when we are dividing it, how many elements are there? How many elements are there? N by 2 elements. How many elements are here? N by 2 elements, right? That is the same, n elements. We have divided it n by 2 elements, n by 2 elements, correct? Again divide it into two subparts. So it will be n by 4, n by 4, n by 4, n by 4, correct? Now, at this particular level, think of it as a level. At this particular level, how many elements are there? N elements, correct? At this particular level, only this. How many elements are there? Again n elements, correct? Again n elements. So again n elements. At this level also again n elements, right? So at each and every level we are sure that each and every level will have n elements, correct? Now uh, one thing, so here also n elements, here also n elements, here also n elements. So up till like what count I will be getting the n elements, that will be my complexity. Basically n multiply by that count which we are getting, the basically the size of this tree, the size of this recursive tree, the depth of this recursive tree, which I will be getting multiplied by the n elements. What I'm saying is the height of the tree basically multiplied by the n elements will be basically my time complexity, right? So we are aware that each and every level has n elements, but are we aware of the height? Not yet, right? Not yet. So how will we get the height? How will we get the height? Look at this. This is n, right? This is n. So we have the first as n. What is the second thing which we are getting? That is n by 2, right? What is this? In the third level, what are we getting? We are getting n by 4. And at the very last of the recursive tree, at the leaves, if we are talking about the leaves, so at the very last, what I will get? What will be the number of element? What will be the number of elements? So it will be 1, right? It will be 1 because this is of one length, correct? So so this will go on up till 1, correct? This will go on up till 1. Now we have to find out how many elements are there from n to 1 following this kind of progression. So what is this? What do you think? You have done it in basic maths, I think. So this is arithmetic progression, correct? Or geometric progression. What is it? This is geometric progression, right? GP. So what happens is basically this is n by 2. Now, what is the formula? What is the formula for the nth element in GP? That is an is equal to ar to the power n minus 1, right? So what is my nth element? What is my nth element? That is 1. Correct. This is my nth element and this is my first element. So nth element is 1, which is 1, is equal to what is my first element, which is n, into 1 by 2. Why 1 by 2? Because the ratio, if you will so see this n and n by 2, what is the ratio? That is 1 by 2, right? 1 by 2 to the power n minus 1. N minus 1 means what is the number of elements? What is the number of elements? Minus 1, correct? So I'm assuming that the number of elements, I mean, which our target will be x, correct? So x minus 1. Now, what I will do is I will bring that n to this side. 1 by n is equal to 1 upon 2 x to the power x minus 1 basically. Now this 1 to the power x minus 1 will be 1, obviously. 1 to the power something will be 1. Now we will bring this to here and then here. Simple maths, basically 2x is equal to 2n. Now what here we will do is we will take log base 2 on both sides. So when we will take log base 2, it will be basically x, and here log base 2 2n, right? Now what we can do is we can write it as 1 plus log base 2n, correct? Now, so this particular result will be basically the height of our recursive tree. This is the height of our recursive tree, or the depth of our recursive tree, we will say it. So this we have got it. Now, what was our time complexity formula? Well, what was our time complexity formula? It was height of the tree multiplied by the n elements, correct? Because here also n, in the second level also n elements, third level also n elements. And so how many times basically? Height of the tree, right? So n multiplied by 1 plus log base 2n, which we can approximately write it as n log 2n, correct? N log base 2n, which is our time complexity for the merge sort. So this is how merge sort basically works and how the recursion works. Because in recursion, the main point is that you do not have to worry about how it will be taken care, how it will be basically processed and all those stuffs. You will assume that I'm getting this result here. I'm getting this result here, and then I will do the further operations on that result, on that expected result. That is what recursion does. So this is how merge sort looks like, and this is the code of it, the pseudo code of it basically. And I hope you like it. I will see you in the next video. Yeah.